Yeah, hi, Sudhi.
Hi, good evening. Hi.
Okay, we will start. Others will join in meantime. Able to see my screen?
Yes.
Just a minute, guys. Some issue. Just give me 1 minute. Okay. So in last class, we have done a specific topics like management access restrictions to a specific IP address, right? If I am having multiple users and they are connected to any of the IP, how can I restrict their access to a specific IP address? So if a user is sitting in a specific VLAN or a specific IP network, then only he should be able to log into firewall. Like not everyone should be able to log into firewall. Okay, that we have checked. Then we have checked routing behaviors, like how does a firewall perform a routing, and how does it check longest match or lowest AD value to have a best path selection. Right. Then we have done one default route configuration in a FortiGate firewall. Any questions in this?
Yeah, can't we make it on host name with IP? You said us like on host name how it is,
What?
computer host name.
No, no,
I
no.
read
There is
host.
no such option available actually.
If the person is like sitting in one location, his IP subnet, the administrator, if he goes for different headquarter or any location, there the subnets will be different. In that case,
You need
he
to
can't.
allow specific subnet of your VLAN, IT VLAN. You cannot have a host name changes in that. There is no such
Okay.
option available.
Okay, and you said like in static route,
Mm-hmm.
000, and if you add zero,
Mm-hmm.
that's the only topic in firewall like for static route
No, no,
concept.
no, no, no. That 0000 was a default route.
Default route you said only that
Correct.
thing is there in the static route like topics.
No, we have like more precise static routes also available that we would
Mm,
be doing for our internal LAN.
okay,
Then we would be having separate topic for a PVR and all that we will see later.
okay, that's
Okay. But for now, see what we have done, how to write a default static route, and why do we need a default static route for internet purpose, right?
yes, yes.
Okay. Then we'll go now with the next topic. So today first we will check like how do you write a static route for your internal VLANs. So the requirement would be, suppose this is your lab topology. Okay, this is my lab topology. Okay, in my lab topology as of now I am having firewall, I am having a L3 switch, and I am having a ISP, internet service provider. Okay, 1 minute. Okay, then I am having an internet service provider in my lab topology. Now see, previously we were having a L1 and we have done like these two ports, we have done a port mapping and all, right? We have done LSCP configuration in previous labs, and switch side also we have done a LSCP configuration. Now we will remove LSCP configuration. We will use only specific topology. Now we will do some changes in our topology for now. Now what we are going to do, let us see. I would be having a firewall. I would be having a L3 switch. Then I would be having a ISP. Okay, between a firewall and L3 switch I would be having only single link connected now. This link would be acting as a L3 link or routing link, okay, between a firewall and L3 switch. Then on a firewall, this port would be port 1. Previously, I was having a port 2 and port 3, right? I was having port 2 and port 3. These links we will disconnect now, and now port 3 I would be using for ISP2. Okay, then port 2 would be remaining in a firewall that we will use later in upcoming classes. So now port 1 would be connecting to my LAN side. This would be my LAN side. Port 4 would be my ISP1. Port 3 would be my ISP2. Then port 2 we will use when we are having MPLS connectivity. Okay. So now let us do specific changes, then we'll move forward. Let's go here. Till then, let me remove this. Okay, let us remove this also. Okay, we are waiting for a couple of minutes. Let us wait. So we are planning to remove interfaces, right? So now let us go to interface. How many interfaces we have configured? Let us see. I am having one aggregated interface. Under aggregated interface, I am having a VLAN interfaces, right? Then I am having a WAN. A LAN is not there as of now. Port 1 is there, which is management interface. So now what all the changes I need to do? Change number 1. Delete aggregated interface, right? Then change number 2. Edit MJMT to LAN. Just a name edit, okay? So to do first change, suppose I wanted to do this particular change. Delete aggregated interface. Aggregated interface is having a VLAN 10 and a VLAN 20, right? So before I delete aggregated interface, I need to delete VLAN 10 and VLAN 20, because whenever you are having anything attached to any of the interface, suppose I am having VLAN 10 interface, and if I am having any route or any policy attached to VLAN 10 interface, I cannot delete that interface, okay? Before deleting VLAN 10 interface, I need to delete a route or a policy, whatever attached to that interface. It is common for all the interfaces. Even suppose if you are having any user and user is called into any policy, you cannot delete that user. You need to delete first policy, then you need to delete that user, okay? Or you need to remove a user from the policy. Okay, so now let us see how you can check if anything is attached to your interface or not. If you go to this, let us go here. Okay. Okay, now you see aggregated interface. On my aggregated interface, I am having 3 references. What all the references are there? Let us see. Aggregated interface is part of VLAN 10 and VLAN 20. And even if I wanted to delete VLAN 10 and VLAN 20, see, these are my VLAN 10, VLAN 20, right? There are also part of some references as of now. So what are that? Let us see. VLAN 10 is part of a DHCP server and one address object group. So now first I need to delete a, suppose directly before deleting this DHCP and all references, if I try to delete a VLAN 10, what will happen? Let us see. I will select a VLAN 10 and there is no delete option available as of now. I cannot delete it before I delete the references. So first I will go, I'll try to delete a reference, select a DHCP and try to delete it. After that, select the address object group, try to delete that. Okay. Now if you try to delete VLAN 10, you can able to delete a VLAN 10 interface. Let us see. I am having a delete option for a VLAN 10 because there is no reference available or it is not called anywhere. If at the same time if I try to delete for VLAN 20, I cannot delete it. So now let us delete VLAN 10. Then I'll go to VLAN 20 and I'll do the same thing. This is not the one. 1 minute. Aggregated interface. Two references of VLAN 20. First delete a DHCP server and delete a VLAN 20 interface address object group. Okay. Then I'll just delete this VLAN 20. Now on my aggregated interface, I am having port number 2 and port number 3 as a members, right? First, I need to remove them from the aggregated interface. Okay, done. Now let us see if I am having any reference in aggregated interface. There is only one reference available. What is that? Address object group. So I can delete address object group. Now if I try to delete aggregated interface, it would be deleted. Okay. So first requirement we have done. Second requirement, we need to change a management interface IP name, right? So let us change. Instead of management, I will say this would be LAN interface. Okay. Now from firewall side we have done. Now from a L3 side, what all the changes we need to do? Let us see in your topology. Previously, VLAN 10 and VLAN 20 gateway, where it was configured? It was configured in a L3 switch. For this PC and this PC gateway, right? It was configured in a firewall. Now we need a VLAN 10 and VLAN 20 gateway, right? So on L3 switch, what we'll do? We will configure VLAN 10 and a VLAN 20 gateway, okay, which is 10.1 and 20.1. Okay, and between this L3 switch and firewall, we need some routing L3 interface. So what we will do? We will configure VLAN 1 with 192.168.100.2. Okay, then we will enable routing between a L3 switch and a firewall. So now let us go to L3 switch. We'll see what all the things are there in L3. Show VLAN brief. We are having 10, 20, 100. Okay. No problem. So what we will do? Configure T. 1 minute. Show IP interface brief. VLAN 100 is not required now. So config T. No problem. Let it be. Interface VLAN 10. IP address 192.168.10.1. No shutdown. Then interface VLAN 20. IP address 192.168.20.1. No shutdown. Okay. Then interface VLAN 1. IP address 192.168.100.2. No shutdown. Okay, done. Let me try to ping a firewall IP 192.168.100.1. We'll wait for a couple of minutes. Now I am able to ping a firewall IP, right? Show VLAN brief. So port number 0/2 part of VLAN 10, 0/3 part of VLAN 20. Then rest all part of VLAN 1. That's fine for us as of now. So I will save this configuration for now. Now what is the next change we need to do? We have done like core switch configuration in our lab environment, and we have done a gateway and everything, right? So now let us go to VPC, show IP. I don't have a IP 192.168.10.100/24 192.168.10.1. Okay, so that's it. Okay, show IP 192.168.20.1/24, sorry, 20.100 20.1. Okay, so now we will try to do some exercise from this testing PCs, this VPC 10 and VPC 20. First I will try to ping my gateway. If my gateway is reachable, then what is the next stop? I'll try to ping a firewall. What is a firewall IP? 100.1. If firewall is reachable or not, we will see. Then what is the error or what reply we will get? Let us observe. My gateway is reachable. Okay. Then ping 192.168.100.1. Now it is getting request timeout, right? So from a PC I am not able to reach a firewall. So now we will open a firewall and we'll see if traffic is coming to a firewall or not. Diagnose sniffer. Okay, we will do a debug and we'll see. Diagnose debug flow filter source address 192.168.10.100. Diagnose debug flow trace start 100. Okay, let me again try to ping 100.1. Okay, now let us see. 1 minute. Okay, traffic is coming till a firewall, but what is happening? Let us see now. If we see this particular thing, okay, let us open a notepad. Okay, now what we are able to see, let us see in this particular output. Received a packet. What is it? This is a source IP 10.100. Destination is 100.1 and received from port number 1. This particular traffic came from port number 1. Type 8 means it is a ICMP request traffic. Okay. Then what is happening? Firewall allocated a new session. Then we are checking like message reverse path check failed, traffic is dropped. Whenever you see this particular message, that means firewall received the traffic, but firewall is not having a routing to send the traffic back to this particular destination. Now what will happen? I am the source. I have sent the traffic to firewall. Okay. Then firewall need to reply me, right? But firewall is not having a routing to reply me back. Then you will get a message like reverse path check failed in this particular scenario. Okay. So now what we need to check in firewall? Do I have a route available to send the traffic to 10 dot and 20 dot? Let us see. Diagnose debug flow trace stop. I'll stop diagnose. Then to check a routing table, get router info, routing table all. Okay. As of now, I am having a route available 100 dot series, then 192.168 100 dot series, then 00 default route. But 192.168 10 dot series is not available in my firewall. Okay, so this particular routes will not be getting a reverse traffic will not get to this particular user. Now what we need to do at a firewall level, we need to have two routes at a firewall, so traffic will come back to this particular user. Okay, so now firewall we will do two specific routes. We call this like a internal routes. Why? Because we have two VLANs in my environment, right? VLAN 10 and a VLAN 20. Whenever this particular user sends a traffic to firewall, firewall need to reply them back, right? So we need two specific static routes, or if you run a routing protocol between your L3 and the firewall also fine. We will do that in upcoming classes. So we need two specific routes at my L3 switch for a VLAN 10 and a VLAN 20 pointing towards my L3 switch. What is my L3 switch IP? 100.2. Okay, let us do that now. Is it clear?
Yes.
Okay. Okay, 1 minute. So we'll go to static route. Now I need to write the route for 192.168, sorry, 10.0/24, and my next hop should be 100.2. It will point towards my LAN site. Okay. Then second thing, 192.168, 20.0/24, 100.2. It will again point to my LAN site. Okay. So I am having two routes now towards my LAN switch. Now we will try again, try to ping. Previously we were getting request timeout, right? Now I am able to ping firewall, correct? Now we will go to second switch also, second PC. First let me ping my gateway. My gateway I am able to ping. So now let me try to ping a firewall. Firewall also I am able to ping now from both the VPCs, right? So if you don't have a reverse route, you will not be able to reach a firewall at all. Then forget about the internet and everything. So whenever you have this type of scenarios, or your L3 switch is acting as your inter VLAN routing, then you need to have a L3 between your you need to have a routing between your L3 and your firewall. From L3 you should have a default route to firewall, and from firewall you should have a VLAN routes towards your L3 switch. Okay, then your internet would be functioning in your environment. Is it clear?
Yes. Clear.
Okay, so one more thing, from my L3 side, I will just do a default route for internet purpose. 192.168.100.1. Okay, done. Now, see, till now whatever we have done, we had a new firewall, we have configured basic things, we have configured interfaces, okay, like LAN interface, WAN interface. Then we have safeguard our firewall for the user logins. We have created specific users based on our requirement, admin users, right, with the profiles. Then we have done a IP based restrictions, only specific IPs can be logged into our firewall. After that we have done a routing. From a routing we have just done a default route and a basic static route towards our LAN site. Still our users, these users will not be able to reach our internet, because there are certain more things we need at a firewall level to get a basic internet access for a users, right? So now,
One doubt I have.
mhm.
Whenever routing, like static routing or any default routing or any routing happens, we have to write reverse route also between firewall or switch, or how it is.
No, 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 no. See, this was not a reverse route. This we are saying a firewall. If whenever you want to send the traffic to 10.0 or 20.0, please send traffic to your L3 switch. Okay. And see, whenever you want firewall want to send any traffic to anyone, he should be having a route, or else he cannot send the traffic, right?
Okay.
So now next topic or next agenda of our training would be to provide internet access to this user and this user. Okay, so for that we would need a security policy, but before that let us understand how security policies works in FortiGate, then we'll move forward. Okay, so now we have done this part. Now let us understand the traffic flow, then LAN to WAN policy. Before that let us go to like FortiGate firewall architecture. Okay, hardware architecture in FortiGate firewall, what all the chips we would be having, let us see now. So where is a PDF? Okay, okay. So in FortiGate firewall we are generally having two types of chips. Okay, one is called a NP chip or network processor, and one is called a CP chip or content processor. Apart from this, we are having one more chip we call the CPU central processing unit in FortiGate firewall. Okay, so first chip, let us go for a NP. NP is called a network processor. What is the role of this NP chip? Perform hardware acceleration for network traffic. It is like a data plane of your firewall. Okay, functions offload packet processing, VLAN tagging, link aggregation, and some IPsec VPN encryptions at the interface level. Enable fast path processing where subsequent packets in the session skips the main CPU. So how does it works? Let us see now. Then again we'll come to this thing. So now this is your firewall. This is your LAN interface. This is your WAN interface. Okay, WAN, or you can say ISP also, doesn't matter. This is your L3 switch. This is your user. When the traffic comes to your firewall, okay, from a user, traffic came into your firewall LAN interface. Okay, so always remember initial checking. Initial checking always done by CPU. So what all things firewall will check? Like IP headers. Do I have a routing available or not to forward this packet? Do I have a policy available or not to forward this packet? Everything initial checking. Do I have to do a NATing and all? First everything initial packet would be checked by a CPU. Okay, suppose this PC sent a first packet, packet number 1. So this packet would be checked by a CPU. Then after that he is sending a subsequent packets like packet 2 or packet 3 for the same data, packet 2 or packet 3, whatever packets he is sending. So now CPU will not come into a picture every time. Okay, CPU checked everything and allocated a new session. Okay, now CPU will not come into a picture. Now CPU will offload his work. Okay, first packet checked by CPU, then second packet, third packet, whatever subsequent packets will come, that would be offloaded. Offloaded to whom? Offloaded to NP engine. Okay, NP processor for routing purpose. Okay, or for forwarding purpose. Is it clear? So after initially CPU checks everything, then whatever data need to be forwarded, CPU will not come into a picture. CPU will offload that particular packets to our NP processor or network processor to do a fast path checking or to send the packets fastly. Okay, that is called NP offloading in our FortiGate firewall. So what all the things NP processor will handle? He will handle like VLAN taggings, link aggregations or LSCPs, or he can also handle VPN traffic, IPsec tunnel traffic at the interface level. Okay, is it clear? Okay. Then after that, second chip will come into a picture. After the NP will send the traffic. See, at the initial stage, CPU was checking routing as well as policy, right? But after NP will do a policy check, and what will happen? A CP checked and he allocated a session. Okay, then every time policy will not be checked every time. Now policy checking will not happen if you are having an existing session. There is no policy check happening, but still the content filtering or a virus scanning you can say IPS scanning. That would be continuously happening. And NP processor work is only to handle a network task. Okay, 1 minute. I mean to say NP processor can only do your routing part or a forwarding part, but he cannot check IPS signatures or URL filtering, web filtering, application control and all. So again, NP will give this particular content filtering task to your CP content processors. Okay, then content processor will check if this particular packet need to be allowed or any virus or anything. Then again he will send this packet back. After checking, he will do his checks. Then after he do his checks, he will again give packet to your NP processor, network processor. Then he will send out packet to your exit interface. Okay. Usually this type of frame will happen whenever you have a packets in your FortiGate firewall. Okay. Now let us see again. So what all the steps will happen? Assume traffic came and the CPU allowed this traffic or policy is allowed. So traffic came into in interface. So this would be handled by your NP processor now. Then we need to check a routing. So NP processor will check this. Then policy will not be checked because already session is there. So okay, before routing, do I have a session? If I have a session, yes, then no policy check will happen. Then you can say like a bypass and go to fast path. That means the policy check will not happen now. The routing will check a NP. Then routing will offload this CP. Why he will offload to CP? For security scans. Again CP will check allowed or not allowed. Then again it would be sending back to your NP. If it is allowed, sending back to your NP for exit interface. Okay. Then NP will do your NAT and send a packet out. So this would be general scenario you would be having when you are having a FortiGate firewall. And this is NP and CP will come into a picture when you are having a second packet or subsequent packets. Okay. Is it clear? So role of NP you understood. So role of CP, accelerate or resources intensive security inspections. So he will take the load of CPU to check IPS signatures, application control or complex encryption decryption. Okay. So reduce the load of main CPU when performing deep packet inspections and maintain high performance even with security feature enabled. So what is the role of our CP engine or content processor? To do our flow based antivirus scanning or your encryption decryption, application control, IPS signatures scanning. Okay. Usually if you don't have a CP, everything need to be performed by your CPU, central processing unit, and your firewall should go high or firewall processing will go high. Okay. So if you don't want the firewall to perform everything, so we will say CP, we will do some offloading to our CP. Okay. Is it clear? Okay. Then this is general traffic flow behavior in our FortiGate firewall. Traffic came to your interface, then firewall, these all things would be checked by your CPU. Okay. Then your IPsec VPN encryption decryption generally happens at your NP engine if it is second packet. If it is first packet, CPU will handle this. Then this administration control task generally handled by your CPU. Then you see this destination NAT, routing, policy, lookup zone and all, session helper. Then these all things, if it is a routing part, it would be handled by your NP. There are certain things like device identification, user authentication that would be handled by your CP again. Okay. Then routing and your NP engine will check all these things. Then send the traffic to your UTM bundle. UTM bundle means your content processor. All these things, your security scannings will happen at your content processor. Okay. Then content processor will send the traffic again to your NP engine to send the traffic out of your firewall. Like see, traffic came in this way. All these scannings happen at your firewall level. Okay. In this you would be having a mix of like NP and a CPU. Both will check their own specific roles, then send the traffic to your CP engine for content scanning or IPS scanning. Then IPS will again send the traffic to your NP for sending a traffic out to your destination or send out to your destination. Okay, is it clear?
Yeah, clear.
Okay, so now if we go with the steps, what all things we need generally. If you don't go to a theory, what all things you need in a basic. When the traffic came in to your firewall will do first what it will do. These things, if you don't have a DOS policy, these things we don't need to configure. These things we don't need to configure. I am assuming IPsec is not configured as of now. So first thing it will come to your routing. Do I have a route or not? Firewall will check first thing. Then after that, it will check session stateful inspection, policy lookup, and all. That means it will check a policy. Okay. After that, after policy check, it will check if you have a UTM. I am assuming I am not having any web filtering or anything as of now. After that, it will check NAT configuration. Then it will send out to your exit interface. Okay. So at this stage, what all things we are having? Traffic coming to in interface. Anyhow, we are having a interface configuration done, right? So this is done for us. Routing we have configured now. So next we need to configure policy and we need to configure NAT. Correct? Is it clear? See, we could have
Yeah,
configured
clear.
policy directly, but how the
The
traffic
UTM would be used in only web ratings or
URL filtering, IPS signatures, application control. That is all
okay.
for a UTM. Yeah.
Okay.
So now we need to write our first security policy. So now let us see. We'll come to this later. Before that, 1 minute. Hold on. Okay, no problem. So now what we will do from this particular user, we will try to go to internet. So generally we will try to ping 8.8.8.8 and we'll see if we are getting a reply. If you are not getting a reply, where it is getting stuck, we will try to understand in a firewall policy. Okay. So we'll go here. I was able to reach till firewall now, so I will try to reach 8.8.8.8. We are getting request timeout. So now let us open a firewall and we'll see where it is getting blocked. Again I will do a debug flow to check what is happening in a firewall level. Okay, is it clear?
Yeah, clear.
Diagnose, debug, flow, filter. So in a filter you have multiple options available, like whenever you do debug with the filter, you have source address, destination address, source port, destination port and all. So as of now we will say I want to filter traffic of source address 192.168.10.100. Okay, then I will enable filter, diagnose, debug, flow, trace, start. 100 means 100 packets I wanted to capture in my environment for now. So I'll go to VLAN 10. I will say 8.8. First packet came, second packet came. That should be enough for us now. Let us copy these things. Just a minute, guys. Sorry all. So now we have done a packet capture, right? So now let us see. This is our packet capture output. Am I audible, guys? Hello.
Yes, you are audible.
Yeah. Okay. So now we received a packet again. This is our source, and we are trying to reach 8.8.8.8. Now what happened? Let us go to our packet, our diagram also. 1 minute. So this is our diagram. I'll try to copy this and paste. I'm not sure if it will happen or not. Okay. We'll go with this diagram, and let us see. I'll try to copy this also. This is our debug outflow, right? So now if you see, packet came from our source address 192.168. Then after that packet came, what firewall will check? It will check if I am having a session. If I am not having a session, firewall allocated a new session. After that, what it will check? It will check a routing. Do I have a route? Find a route, and I found a route via this particular address. 1 minute. Good looking. Okay. Okay. So after finding a session or allocated a new session, usually for a ping, every packet they would be allocating a new session. Okay, if you are having a TCP, they would be session created for a TCP connections. Okay, but the ping there would be no session created, because only it is like there would be no communication or no SYN packets or anything, right? Only ping reply will go, request will go, and ping reply will come. That's all. Then for second packet, again new request, new reply. So there would be no much sessions created for ping. So usually ping will be handled by your CPU only. So allocated a new session. Then after that, found a route, and the traffic is going via your gateway. So routing also performed. Then after that, you need to check a policy. So you see message denied by forward policy, policy number 0. And what it is saying, denied. As of now, traffic is not allowed from a policy, because we are having a policy number 0, which is implicit deny. Implicit deny means if you don't have any specific policy above this to allow any traffic, traffic will by default hit this, and you will see like a deny or request timeout or internet not available at your user side. Okay. So whenever you see your network is not available or users are not able to access, first check if it is allowed from a policy. If it is not allowed, traffic will go to your policy number 0. Okay. So what was happening in this scenario? Point number 1, traffic came from port number 1. You can see received a packet from port number 1, right? After that, allocated a new session, and this would be very common when you are having a ping packets. After that, check the routing. After that, check the policy. So as of now, this is done, this is done, this is done, and we are getting drops at a policy level, right? So we need to create a new policy in a FortiGate to allow this particular traffic. Okay, is it clear?
Yes.
Okay. So to allow policy, what all things you need? Whenever you try to create any policy in FortiGate firewall, you need a specific things. You need an incoming interface. You need an outgoing interface. Then you need a source address. Then destination address. Then port number. This would be services, TCP or UDP services. If you want, you can select this as a all also. Doesn't matter. Okay, these are the common things you need in your firewall policy whenever you want it to do. The optional things are like a user is optional, NAT configuration is optional, but required when you want a internet access. Whenever your user wants to go to internet, NAT is mandatory. Okay, so users would be generally optional, where if you want you can configure, or else you don't need to configure. Then there would be a schedule option, like your policy you wanted to be allowed only on a specific time or a duration, you can do a schedule, that is also optional. Okay, is it clear?
Yeah, clear. If that NAT is enabled, so internet will go from the firewall to user, right? If they are using the same policy.
Correct.
Okay, okay. Maybe if I connected a VPN also, if NAT is enabled, all the internet traffic and everything will go from firewall to user, right? They no need to have the
No, no, no,
internet.
no, 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 no. For
It's
a
it's
VPN, that is
it's
all.
different.
VPN, it is separate topic altogether. It depends how you
Uh,
configured your VPN.
so the NAT will be um,
NAT is
working
compulsory for
basis of.
going out of internet. If a traffic is going to firewall, going via
Okay,
firewall to internet, NAT is compulsory. But how VPN traffic
okay,
is handled, that we need to check from a VPN configuration also.
okay, okay. So the same NAT will use in different functions in different
No, no,
places,
no.
right?
NAT function is the same only, but your VPN function
Uh-huh.
would be different. If you are configuring
Oh,
a full
okay,
tunnel or
okay,
a split tunnel, that will come into picture.
okay, 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 got it.
Okay. Yeah. Okay. So these are the common things we would need whenever we are configuring a firewall policy. So for our policy, we know incoming interface is our port number 1. How we got to know? If I did a debug, I got to know, right? If you see, traffic came from which interface? Port number 1. And traffic is going out via which interface? Port number 4. So now incoming and outgoing interface we already know from our debug. So outgoing interface is port number 4. Then source address would be, this is a source address. So for giving a source address in the policy, you need to create an address object in a FortiGate firewall. So whenever you create an object, there are multiple options available. Address, either you create a specific host object, or you create a subnet, or you create a range of addresses. Okay. So for now, what we will do, we will create a two objects. One object would be VLAN 10 subnet, and another object would be VLAN 20 subnet. Okay. The destination, whenever you go for internet, destination would be any or all in a FortiGate firewall. Is it clear? So now
Yes.
let us create objects first, VLAN 10 and VLAN 20 object. So I'll go to firewall login.
While creating policies, there is another option. Logging something will be there now.
Yeah, we'll check that.
What it?
We'll check that. First, let us create objects. We'll go to policy. I'll show you what all options you will get. Okay. For creating an object, I'll select a address. I will say VLAN 10. Sorry, VLAN 10. Then under the type, I am having like subnet, IP range, FQDN, geographical locations, or a dynamic means if I am having FSSO users and all. If you see FSSO fabric connectors, single sign-on users, that will come into picture. Or even if I wanted MAC based access policies, I can do MAC based. So as of now, we'll go to subnet. Then 192.168.10.0/24. Okay, configure this. Then another subnet, I will say VLAN 20 subnet only, 192.168.20.0/24. Okay, these two subnets we have configured, and we want to allow internet for these two subnets for now. Now I'll go to firewall policy. I'll try to create a new policy. Just we need to give a name like LAN to WAN, or whatever name you prefer in your environment you can give. Then we need to select the incoming interface. For us, incoming interface is port number 1, which is LAN. Then outgoing interface is port number 4, which is WAN. Then you see here source address. We need to select a specific source address you wanted to allow. So I will say VLAN 10 and VLAN 20 would be my source addresses. Then destination would be all for me. Then services, I can select a specific service if I want, or if I want to allow all, I can select all. For now, I will select all. These are the services, like if you want to allow HTTP, if you want to allow HTTPS, if you want to allow DNS, there would be specific service you can select. Okay. what type of traffic is going via your firewall policy. Then this would be the action object action. Then you see here NAT. Just now we will enable a NAT. What is a NAT, how it works and all we'll see in upcoming classes. There would be separate topic for a NAT. Security profiles also we'll see in the next class. So you see here log traffic. So if you say security events, only which traffic is getting denied from this policy would be logged. If you say all events, if traffic is passing from this particular firewall, it would be logged in your traffic logs. Okay, whenever you see from a log and report, your traffic would be logged during this policy transfer. Then you see generate traffic when the session starts. When the traffic is coming to your firewall, that time firewall will check do a logging capture. If you don't select this, when the session is completed, then only firewall will capture these logs. Okay. Then packet capture. If you wanted to allow packet capture on the policy, you can allow it. So I will say enable this policy and click on OK. Is it clear?
Yeah, and what about the flow thing
What flow?
called um, flowing something proxy flow? We
We'll
just
come
go
to
to
that.
the firewall.
Inspection modes are there. We'll come to that.
Oh, okay, okay.
Inspection modes, right? Flow based or proxy based.
Yeah, instruction flow
Yeah,
based or proxy
yeah.
based.
We'll come to that in
Okay.
next class. Okay, don't worry.
O-
There
Okay,
should
if it's a
be
future topic, no problem.
yeah, it would be there. 1 minute. There should be see proxy based or flow based. We will come to that. No problem.
Okay.
Yeah. Okay. So now we have allowed the firewall policy. So now let us see again. We'll go here. Before that, let me do a debug again at the firewall. Diagnose. Wait. Diagnose, debug, flow, filter, source address 192.
Now you created only one policies for 2 VLAN.
Correct.
We can create individual also, correct?
Yeah, yeah. We can create individual also.
Okay.
Okay. Now I will again do start a ping from VLAN 10. Now we are getting a ping reply, right? So now again we'll take this particular output and we'll see what is happening. Okay. So previously also we were getting similar output, right? What is the difference now? Traffic came, source is this, destination is this, and came from port number 1 only. Then allocated a new session again. Then again found a route. Then this would be a NAT option. Then it is allowed from policy number 1. If you see message allowed from policy number 1. But previous output, what was the difference? Let us see. Previously it was getting denied. You see message denied by forward policy. But now after we create a policy, what is happening? Allowed from policy number 1, right? If you see now, previously the message was
Yes,
getting
yes.
denied. Now allowed from policy number 1. Then the NAT will happen and send it to this particular. This is a NAT IP as of now. So how does a NAT works and all, we'll see that later. But for now, if you focus on like when the packet came in, it checked the session. If there is existing session available, it will go to there. If no session available, allocated a new session. Then it will check a routing. After routing performed, it will check a policy. Okay, if policy is allowed, traffic would be allowed. If policy is denied, traffic would be denied. Okay, is it clear?
Yeah, there are
Yeah,
some
okay.
predefined objects already, and those, what are those?
1 minute. Okay, when it comes to predefined objects, if you go to address, you are having like this is SSL VPN object you are having, or firewall authentication port address, which would be 00. Then you would be having like FQDN names, predefined FQDN names would be available. Then if you search here, you would be having all, which means any. Okay, So these are like suppose whenever you configure a VPN in your firewall and you want to configure SSL VPN, generally this would be taken into a picture for SSL VPN. Okay, then this we have created, this we have created. Then whenever you configure a internet policy, generally you will select as a all, which means that would be taken in from this particular place. Then predefined FQDNs like common FQDNs has been configured in a firewall, that would be there. Then there are more predefined objects, we call it, that is service objects. Yeah.
Yeah, actually, if you are configuring VPN
Mm-hmm.
and if I am assigning some, just consider some storage is there, okay,
Mm-hmm.
and there is some IP, and I am giving that IP in the policy, but the same destination, if I want to access through FQDN, then I need to add another address object in the same policy, right?
Yeah. No. See, this is predefined object means this is not compulsory to use. This is just an object created in a
Oh,
firewall. You don't
okay,
need to
okay.
use this
Yeah, what
mandatory. You can create your own object and configure in your SSL VPN also.
that is fine. What I'm asking, just consider if I'm having some 10.0.0.1.
Mm-hmm.
Okay, that is
Mm-hmm.
one server, one
Mm-hmm.
server. But
Mm-hmm.
in real time, if you connected in the environment, okay, if you connected in the environment, like I can use the same destination through IP address, or else I can access through FQDN with some name. Okay. If I
Mm-hmm.
want to use the same kind of scenario in VPN, I need to have a two address objects, right? One is IP address, another one is FQDN,
No,
right?
no, 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 no. Not required. Not required.
Not
That is
required,
not the
right?
scenario. No. See,
Okay. Okay.
FQDN works first thing. Now I understood your concept, what you are trying to say. Let us see.
Okay.
You are having a firewall. Inside your
Yes.
firewall, you are having some switches, and here you are having some type of
Yes.
server.
Yes.
Now your firewall is connected via internet WAN, right? And over WAN, you are having some user.
Okay.
Okay, he is trying to connect to your firewall using a VPN, SSL VPN
Mm,
or IPsec VPN. Okay, and he is trying to access your server not with the IP address but with the FQDN, right?
yes.
So now here comes the two things. Whenever user types FQDN in a browser, his PC is resolving FQDN by how? Do you have a local host entry? If no, if your firewall is acting as a DNS server, if no, you would be having internal DNS server also, right? So
Yes.
what will happen whenever you configure firewall or IPsec VPN, you would be having an option like DNS IP. Whenever you connect IPsec VPN, okay, your user will get IP address. With the help of IP address, IP address, he will get a DNS address also. Okay. So
Mm,
firewall, whenever user try to access a browser FQDN using a browser, he will send a request to your DNS server. Okay. So in a firewall, you need to have a policy. Source would be your user. Destination
okay.
would be your DNS server. Okay. Then port number would be
Okay.
your 53 DNS port. This should be allowed. Okay. Then DNS
Okay.
traffic would be
Okay.
allowed. Then for your FQDN, you don't need to allow FQDN in your security policy. Second policy you need a user would be source would be user, destination would be your server, then whatever port your server is running. Okay. And then this should be allowed.
Okay.
You don't need FQDN and IP in same policy.
Okay. Okay.
Okay.
Okay.
Mm. So any other questions? Okay, if no questions, we'll wind up for today. If you have any questions, we can extend for a couple of minutes.
We can just recap one more time in today's
Okay,
session.
1 minute. Yeah. So what we have done today, let us see. First we have done our core switch configuration. Why we have done? Because we need a VLAN gateways on core switch, right?
Yes.
Then we have removed aggregated interfaces from firewall. Okay, there would be no LSCP interfaces on firewall now. After that, we have done a static route towards a LAN. Why we have done? Because firewall was getting like no routing available for VLAN 10 and VLAN 20, right?
Yes.
So we have done a reverse route or a routing bit from a firewall to our LAN side or our VLAN side. Then after that we have understood what is the use of NP processor and what is a CP content processor, and how does the CPU handles traffic. Initial traffic whatever comes, that would be handled by CPU. Then after that, if anything related to routing, it would be given to NP processor, and anything related to security scanning, it would be given to your content processor. Okay, that we have understood now. Then after that we have checked how firewall checks or traffic flow happens, like traffic came into an interface, then allocated new session. Then after that firewall will check a routing. After that firewall will check a policy. Then NAT will happen and send to our exit interface, right? And in between we were having like routing is available, everything is available, but getting dropped at a policy. So we wrote a new policy. Okay. Then whenever we write a policy, we need to have a specific things in a place to write any policy, right? Like what is a source interface, destination interface, source address, destination address. Then what should be your NAT configuration and all. Then we can just write a policy. Okay. So after writing a policy, we observed that the traffic is flowing for a VLAN 10 and VLAN 20 to internet. Correct?
Yes.
So that was all for today's class. Just go through a video and let me know if you guys have any questions. We'll
Hey, boy,
continue.
one doubt I have.
Mhm.
Like yesterday we discussed the static route, right? In
Mhm.
FortiGate, like if a WAN IP has like longest prefix match number is also same, and administrative number also same, and priority also like distance AD value also same. You
Mhm.
said like ECMP it will do
Mhm.
equal cost
Mhm.
multipath.
Mhm.
In that will, like at the time it will route to different both
No, no,
ISP, or
no,
how
no.
it is like
We will come. The ECMP topic will come in next classes. That time we will see. Don't worry. Yeah.
okay.
So if you go to
And
our
this
labs,
theory document,
this
I
theory
need
document
actually.
also I will share. Yeah. Don't worry. I think I already uploaded in our mega link. Just go through mega link.
That mega link is not opening for me. That's
Arey
why.
yaar. Okay. I will try to share it some other way. Okay. So
Thank you.
what we have covered, see, till now we have just covered this particular labs security policy from LAN to WAN. Okay. Then we would be having a routing protocols. We would be having a redistribution. After that, we would be having ECMP and policy based, right? That time we will discuss how it works. Don't worry. Okay. So thanks all. Thanks for